welcome to my video and welcome to the little corner of my system where I screwed in discrete map and its expander DMAP A/B/C. I want to explain a little bit more in detail how I made the patch that I used for the jam called Discrete Topographics. I think along the way you'll start understanding how discrete map works, and that's pretty much the point of this video. Let me mute everything that's not relevant, at least not at this moment. So this is the sequence that's controlled by discrete map. The sound is just an output, saw output from 3-body. You can use any oscillator you want. I ran it through a filter. I'm using root locus. The gate output here is used to send to a slew generator, a function generator if you will. This generates an envelope that I use for the level of the sound. There's a VCA in root locus, so I'm controlling that. There's also an output of the DMAP of the expander here. Let me figure out which output this was. It's the B output. The B output is sent to a function generator, which generates an envelope that controls the frequency of the filter. So there's an output of the gate that's creating a slew, an ASR envelope. This controls the level, and one of the outputs of the DMAP expander here. These are, well, you could consider those accents because you choose which steps are routed through to the B output. Currently that's every step except the first one. This output is triggering an envelope that's used to control the frequency of my filter. As you can hear if I turn up the CV modulation knob for that. If I take out a few steps by routing them to another output here, you can hear how we get nice and interesting accents. I used it subtly and with a little bit more cue. This filter sounds really wonderful if you start driving it a little bit. But well, let's keep it down. You can see that I used a stack cable here for the gate output. So one is going to the ASR envelope that's controlling the level of this sound. Another cable here is, no, it's actually the stack cable, is going into the clock. Let me zoom out a little bit. This is going into the clock input of this Moskwa 2 sequencer. This is to make sure that the wonky rhythm that we generated with discrete map, which I will get into soon, is followed by the secondary sequencer. Let me bring up the sound that this sequencer is sequencing. And as you can hear, this follows the wonky timing here nicely. There's more stuff going on. I used one of the gate outputs of this expander for this sequencer to clock another sequencer, so this is clocked really slowly once every time this sequencer and the discrete map does one cycle, the other sequencer, and I'm using step 8 for that, is stepping forward one step. And this one controls the bass. There's a bit of sample and hold going on, but I won't get into that. I could have used the end of cycle output of the discrete map here as well. For this purpose, this one triggers every time the cycle restarts on discrete map. The second output of this third sequencer is routed into the transpose input on the discrete map, which is the plus Y output here. Let me reconnect this. And as you can hear, we are transposing the melody that we extract from the FX output here. Please note that this output is going through a quantizer, because the output of discrete map is, well, it's just analog voltages. You really, you can set them precisely so you have a nice, almost quantized melody. But I prefer using a quantizer behind analog sequencers. So that brings me to more the operation of discrete map. So this top row here, let me remove the transposition. The top row here sets the CV for our notes, our volt per octave information. As you can hear, there's an interesting switch here to the left of this slider bank. This sets the range of these sliders. Now I have this set to positive but divided by 2. This means that I have more precise control but less range. If I set this to the center position, we have full range of positive voltages. This is ideal if you want to run sequences with, well, a big span. But I prefer to set it in a divide by 2 setting there. There's also a plus and minus setting here. This generates negative voltages when you stay below the center line. This is actually a really nice sequence. Reminds me of some classical piece that I can't remember the name of. Let's hear how this sounds with the secondary melody. I'm just curious. And as you can hear, if you start playing around with just a few settings on the discrete map, it's already a treasure trove for cool melodies and cool rhythms as well. Speaking about rhythms, the lower bank here controls the rhythm of our sequence. In the length setting here, which we choose with this switch here, these sliders control the relative length of the steps. Imagine that you have one bar divided into 8 equal steps. And at the start of all these steps, a note is triggered, a gate is generated, which we can control the length of with this knob, by the way. But with these sliders, we can shift around the edges of those 8 equal steps. So the total length will always be the same, will always be 1 bar, depending on the divisions that you use, of course. But the relative length between the nodes is being changed. Let me demonstrate this by setting these all to the center-ish position. Now we have a relatively boring sequence that we can make with every analog sequencer out there. But if we start playing around with the relative length, relative timing here, you can hear how we can create really interesting stuff. It's this tempo that's coming out of the gate output. That's why I'm using this one to clock my secondary sequencer, so it really follows the wonkiness. Now if we set this to position, everything changes. At that point, the sliders just control the thresholds for the internal comparators. And the comparators look at the internal saw wave, which we can see a depiction of when we watch these LEDs. And whenever the saw wave crosses one of the thresholds, that particular stage will trigger. You'll see when I switch this to the position setting that the order of the stages will be completely different. I think this stage will trigger first because this is the lowest threshold, so the saw wave will reach that voltage first. Let's just switch it to position and see what happens. As you can see, this changes everything. Now if we want the notes to trigger consecutively, we have to set these sliders to kind of a saw wave ourselves. Well, the shape of a ramp. Now the length of a bar will never change because the length of a bar is controlled by the internal clock, which is this, well, which is an internal saw wave LFO. We can switch this internal saw wave LFO to audio rates, which for this patch makes no sense, but well, you can, and then you have full proactive control over the frequency of this internal saw wave. So what else is there to talk about? You can change out the internal saw or ramp wave by something else that you can patch up here. When you are using the internal saw wave, it's best to keep these switches into the up position if you want every stage to trigger. You'll see when I set these to off, only the ones that are set to rise will trigger. You can see if I set these to fall that this is indeed that they are indeed not triggering either. This is because the internal comparators look at either the rising edge or the falling edge of the internal clock. Because a saw wave only has a rising edge it's smart to set these to rise. But if you send in your own LFO to use as a clock, for example, a triangle LFO, there will be moments that the clock, the internal LFO that is used as a clock is falling. And if you want the stages to react at those settings, you have to set these to the lower setting of this switch. I should be able to demonstrate this if I can find a cable that is not 3 meters long. Let's just use this one. So this is a triangle wave. Let me slow this down. And as you can see, let me set these to like similar settings here. Like the first 4 and the last 4 are set to similar settings. But the first 4 only react to when the triangle clock is rising. And then the last 4 here only react to when the triangle is falling. Let's remove the external LFO. Let's go back to the length mode. And let's find an interesting setting for the length sliders. Let's change out the melody a little bit. Something like that. Let's bring in the secondary melody again. We can sync discrete map to an external clock by sending an external clock into the sync input. You can also use the sync divided by n input. And this knob lets you choose how many divisions or how many steps of the external clock should before the internal LFO here is resetted. Let me try and connect an LED cable here. So I have Pamela's new workout running a clock here. I hope you can see the clock rate by watching the LED cable. Now if I send this into the sync input, you can see that saw wave is resetted immediately, so it doesn't have time to reach very far. It can only do the first 2 stages here. We can increase the clock speed. Independently of the synced clock. So this sync only resets the internal saw or ramp wave. We can send this clock into the sync divided by n input, and this lets us, let me play around a bit with the settings here, and this lets us choose how many clocks will come into the system before the LFO gets resetted. And this means we can let it, or we can divide this external clock by just the right amount so the 8 stages have time to happen. Something like this. I don't know if this loop/once knob or switch will do anything in this mode. I think this would make more sense to demonstrate differently. So when we set this switch to loop, or no, to loop, well, if we set it to loop, the internal ramp wave or saw wave keeps looping, keeps restarting. But if we set this to once, it just cycles once and then it waits for the next reset trigger. So if we, maybe I can make a slow clock here. No, let's do it differently. So this is a really slow clock. Let's make it even slower. Let's send this to the sync input here. If we increase the speed of the internal ramp, you can see it runs through one cycle of the ramp or saw wave, and then it waits for the next sync trigger. You can still use the sync divide by n here to divide this trigger, this clock trigger, even further. Now it will only restart its cycle every so many clock triggers. I didn't count, but I think it was 5 or 6. It depends on the position of this little knob here. Let's remove all this. Let's set this to loop again. And as you can see, our secondary sequencer still follows along, which is very nice. What else is there to show? Maybe I can demonstrate how the above and the below inputs work. These inputs kind of restrict, well, they make the range of the sliders more narrow. We still have the full physical range of the sliders, but they control a smaller portion of the saw wave, if that makes sense. So now I'm sending in 5 volts here, so nothing has changed. Let's turn down the manual offset that I'm sending into the above input here, down. Currently it's at 0 volts. And you can also see from the LEDs that we are only controlling portion of the LFO range here. You can turn it even down into negative voltages. Now the sliders operate within a really small range of the internal LFO, or the internal, well, the relative settings for the gate. It's confusing to talk about, but I'm sure you kind of understand what I mean. We can do the same thing with the below input. This restricts the range of the sliders, but from below. So now I'm sending in 5 volt, which means the lower threshold is completely up. So there's almost no range here. When I start turning it down, we have a similar situation than before with the above input. This is just a clever way to control all the stages, all the timing of all the stages with one CV. Let me just send in a chaotic oscillator here, and you will hear that Now we have almost a random situation happening. And well, the secondary oscillator is still following along. I'm sure the bass is still following along as well. Let's talk briefly about the DMAP A/B/C expander here. I have the first step here switched to A. What you do with these switches is choose which of the stages is routed to one particular output. There's 3 possible outputs, so these are 3-way switches. The first one is used to reset my external sequencer on the first step, so this means these 2 are always starting at the same stage. Let me unmute my kick drum on my mixer. You probably cannot see this, but the third stage here on the DMAP expander is set to the C output, and the C output is being used to trigger my kick drum. The 6th step is also, well, the 6th and the 7th step were also routed to the C. I turned those to the center position, so now only the 3rd step here is triggering the kick drum. The B setting, which is the center position for this switch, is, well, like I told in the beginning, controlling the accents. It's controlling an envelope that's controlling the frequency of the filter. Let me turn that up a little bit. So if I set everything to the C output here, we have less accents. And I think it's an interesting way you can program linear drums with this, but also in dispatch. The accents never happen when the kick drum happens, but that's interesting. That's probably not how you would program this if you had all the options. There's also this center section, which are inputs. You can send in CV signal here. You can attenuate the CV signal with the recording knobs, and then this will change, the CV will change the threshold, which has something to do with the setting of these sliders for the according group. So right now the 3rd switch is set to C here, which is connected to the C output, and this is triggering our kick drum. So if I send a CV signal into the C input, this will only affect the threshold of the 3rd stage here. I know it's a little bit confusing, but I hope it makes sense. Then there's this sequential switch here that switches between 3 inputs to one output, or one output to, or one input, sorry, to 3 outputs. I'm getting confused here myself. Apologies. You can use this in tandem with these switches whenever a stage is active. Whenever, well, imagine this same situation here where the 3rd stage is set to C. Whenever the clock passes the 3rd stage, the C input would be routed through to this output. and vice versa. If we send in something here, whenever the third stage is active, this input would be routed through to C. When no stages are active, there's nothing going through here. I haven't studied the expander thoroughly yet. I haven't tried out all these settings, but I thought it would be interesting to at least cover the basics of these in this video. I think I talked about most features on this awesome module. Thanks again to Evan for sending me these 2 units for me to try out. If you have more questions, please let me know. I will make more videos about these 2. Yeah, I think this will be it for this video. I hope you learned something. I'll see you next time. Bye. Oh, by the way, I forgot to talk about the external input. This has something to do with sending in a gate here, like disables a step. I haven't figured that one out, so maybe in the next video. Bye.